Hello students, good morning. Today's presentation we are going to see about the well logging methods and also the interpretation of different well logs, how you are doing from your well logging sheet. So this is your well logging methods. So here we are having different characteristics which are shown here. You can see here in our table, you can see what are the different wireline loggings used in the petroleum industry. So you can see the table very clearly. Name of the log and what are the passive measurements. Also it is shown here, and also the log response effect by the formation fluids and log response independent of formation fluids. For example, name of the log as shown, and the caliper log, gamma ray, GR, then SP log also shown here, and also the caliper log. For example, action of logging tool is which presses the pads against the sides of your borehole. That is your caliper. And similarly, gamma ray. Gamma ray, here you are using the scintillation of counter detects gamma rays. That is your action logging tool. And SP log. SP log potential or electric logs, which measures the voltage between the electrode pressed to the borehole wall and the electrodes at the land surface. And also here it is shown the log response affected by formation fluids, that is resistivity, and also the photoelectric, that is in the resistivity you can see that is one electrode which has been in borehole, which introduced the current, and the current is measured at the second or third electrodes, etc. Similarly, you can see the characteristics measured, that is your width of the borehole, then natural emission of gamma rays, and that is less than 12 inches of the rock properties, log adjacent to the borehole. Similarly, next is your permeability, log response affected by the formation of the permeability, etc. And also there in the electric log, E-logs, there is a shown here also the between the all the measure characteristics, that is resistivity, then characteristics measured, etc. for all these logs. And the applications. In the characteristics measured, it is shown also the width of the borehole, permeability, and electrical resistivity of the full formations, that is minerals, fluids, including the absorbed water and solids. Like that, this table explains all the things very clearly. For example, photoelectric, acoustic, density, the neutron porosity, then NMR, nuclear magnetic resonance, NMR logging. So you can see the porosity logs in the right hand side. What are the active measurements also very clearly shown here. Then we will go for the next applications of the next table, applications. First one, we can see the caliper locks. So where the width of the drill bit, that is the shale reservoir or washed by salt, etc., and less than the width of the drill bit indicates session of some mud cakes, etc. For the permeable zones where the mud invaded the formations. These are the obligations for the first one that is useful in determining the hole volume or cementing casing. So that is your first one, caliper. Then second one, you can see the gamma rays, GR logging, the distance between the shale radioactivity, that is K, and observed uranium and thorium versus your clean, it is clay free, non-radioactive lithologist. Then the source, the GRA, the source is the large GRA because of redox segregation of uranium from the seawater during the process, and that is the shown here. Then because of high resolution, the vertical direction, it is very useful. Then you can see the spectral gamma ray logs are distinction between K, TH and U. Because of GR can be run in cased holes and it is useful in workover operations also. Then you can see the static forwarded rocks also shown here. Then limitation of other concerns. So the observation is shown CAL, GR, NGS, SGR. SP means spontaneous potential. So this one first observed in 1938 and in 1931, that is spontaneous potential. Then other resistive measurements also shown here. So you can see the resistive measurements, that is determination of nature of or the formation of fluids. Formation fluids are useful in when you determine the resistivity properties. So you can see here the locks, and it is noted by SN, RXO, LLS, FL, FLX, LL3. So these are the notations is shown here. And the right hand side, there is the next one, acoustic logging. So photoelectric we have completed. And next is coming to acoustic. That is transmitter emits the pulse of sound and receiver at some spacing detects the pulse. So the interval transmit time is very slow and the compression of waves are happening. So we are using the determination of porosity because the waves pass faster through these minerals and also through liquids or gases. So you are able to do the lithologic identification. You can see here where this is tight sandstone or porous rock, gas filled sandstone, etc. So it is noted by LSS, BHC or DS1, 1957 it was observed. And the next one is your density gamma rays. The source is emits from gamma rays and detects scattered returning gamma rays. So the density of electrons and the density of formations are measured, and determination of porosity, because the fluids in pores decrease the bulk density of formation. So this is regarding the density gamma, and you can see here the example. So when the density is reported in terms of porosity versus the limestone matrix or tight sandstone, they are also showing some porosity and some tight dolomite stones, and also maybe some unreported negative porosity because of their densities, difference in the densities. So if you go for the sandstone matrix, both tight limestone and dolomite stones have negative porosity. So that is FDC, LDT, and deep HI. This is 1957. Then next one is your neutron porosity. So the source emits neutrons that collide with larger atomic nuclei with little energy loss, but loss of energy in collision with hydrogen atoms, which are the same mass as neutron themselves. Then concentration of hydrogen, determination of porosity. Shale appears to be the hydroxyl ion OH and H2O are absorbed. Clay minerals are determined. And you can see the response. More porous, less porous. You can see here. If the more porous means showing 1.7, then less porous means 3.0. For oil-filled sandstone and water-filled sandstone, tight sandstone, then tight limestone. So these are the observations which are made. And when the density is reported in terms of porosity for the limestone, it shows some porosity and some tight dolomite stones, which has to be a negative porosity. And also, this is commenced in 1938 and is noted as GNT, SNP, CNL, NPHI. Then, so this is your neutron porosity. Then next, that is last column, NMR, nuclear magnetic resonance. So this tool generates the magnetic field and polarize hydrogen atoms of fluids, and the detector measures and decreasing resonance after the when it will be released in the field. So we are calculating the relaxation times T2 of the hydrogen atoms in the fluids, and also determination of size of the pores, the mobility of all the fluids, whether it is a small pore or big pores, and the proportion of liquids or fluids which has been quickly goes through the pore walls. So this is your NMR. In the last one, you can see the pore sizes, smaller 0.3 meter second, larger 2 to 3 seconds. So clay bound water, then capillary water, gas, is a free water, and oil are shown. This in the last. So NMR, nuclear magnetic resonance, is denoted by the symbol NMR, MRIL, CMR. The first developed in 1958. So these are the different types of abbreviations used in the petroleum industry of different well logging methods. That is the basic measurements, that is like porosity and resistivity, etc. So these are the characteristics of wireline logs in the petroleum industry. See, now we can see the limitations. The abbreviations are denoted as CAL, GR, NGR, SGR, SP, and LSS, FDC, GNT, SNB, and NMR, MRL, CMR. These are the tools which is used in the wireline logging methods. Now we can see the interpretation for the gamma ray. So this is example of caliper log, resistivity, and acoustic log. How we are doing the interpretation. You can see the mud cake of porous zone shown by particular depth, and also the shale, then, and also you can see the resistivity deep in ohm meters is shown, caliper is shown in inches, and also next is your neutron porosity log. Also it is shown in percentage of formation, and acoustic or sonic also shown here. So you can easily understand, you can able to interpret, but we will be seeing clearly in our future presentations. The next presentation separately are the interpretation of well logging methods. But here in this presentation, we are only able to give an introduction on the different type of logs used. Wireline logging methods are utilized in the petroleum industry. But in our further presentation, we will see more clearly on GR, caliper, and NMR logs. So this is the example of your interpretation of log sheet. So you can go through it. And so today's presentation, we have completed the well logging methods or different wireline logging methods which are utilized in our petroleum industry. The next lecture presentation, we will see more on individual logging applications like NMR, acoustic, and sonic log, GR, gamma ray, etc. But this presentation briefly gives only the basics. Thank you. Subscribe my channel.